Hi, this is Graham Kilshaw with Interference Technology here at the 2012 Symposium in Pittsburgh. And with us this afternoon we have the famous or infamous Ron Brewer. Welcome, Ron.
Well, thank you very much, Graham. It's a great thing to be here. I've been coming to these things since 1969 and I've missed 4.
And we noted those 4 that you missed.
Oh, you did?
We'll be talking about that later. We've asked Ron to join us this afternoon on this Tuesday, because yesterday was, of course, the moment in time when the NASA project called Curiosity landed on the surface of Mars. And for those of you who don't know Ron, Ron has been working for NASA at the Kennedy Space Center in Florida for about 10 years now. So we're very lucky to have Ron with us this afternoon. And we're going to take a few moments to understand a little bit more what are some of the EMC challenges for space projects. Ron, what can you sort of tell us you think is going on with the space team right now as far as the Curiosity project goes? What sort of challenges do you think they're facing?
Well, right now, Graham, I'm not sure that they're finished celebrating the fact that they made a successful landing on the surface of Mars.
Okay.
Because the feeling there was that this was going to be 7 minutes of terror.
I heard that.
And they advertised it that way.
I think the delivery craft had to slow down from something like 13,000 miles an hour as it entered through Mars' atmosphere. Was that correct? And then slow it down for landing?
Yes, had to go from 13,000 miles an hour to 0.
Unbelievable. Unbelievable.
And live through it.
Now, you're a little familiar with some of the prior Mars projects as well. What kind of problems do you think they had on the prior projects? Rover was one, I forget the name of the other. What sort of challenges did they have?
EMC is a big issue because the systems are very complex and the environment in which they operate is also complex.
Okay.
One of the worst issues that we have on orbit is charging from high energy particles from the sun.
Okay.
So electrostatic discharge is a big issue. And there's nothing you can do about it after you've finally made it into orbit. It has to be solved on the ground first.
Right.
And the NASA mantra is test like you fly like you test. Something that maybe some of us other EMC folk around here might consider to be a wise approach.
It's a very good mantra to have.
Now, on some of the previous spacecraft, the operations were not self-compatible, so the rovers could not simultaneously travel across the surface of Mars or wherever they happen to be, take video shots and radio that information back to Earth at the same time. They actually had to be directed to go to a location. At that point they would stop, then they would do their videotaping, and once they had collected the information for the pictures, radio that back. And that was because of electromagnetic compatibility issues.
So they solved those EMI issues in the past with an operational solution.
Yes,
by moving
correct.
the vehicle around. What kinds of solutions do you think are on hand or available these days to the team to get around those kinds of issues?
Well, we deal with what we call lessons learned, and I can tell you we've learned a lot of lessons over the years, and I have not heard any of the guys from JPL tell me that this latest rover has any kind of EMC problem.
JPL is the Jet Propulsion Lab, right?
Yes, that's correct.
Where is that located?
That's located in Southern California.
Southern California. Okay. Well, let's hope they don't have any problems this year. It's a very exciting mission they're on.
Oh, it certainly is, and it's really interesting to be a part of it.
I saw a couple of the first pictures this morning on TV. It's incredible to think of the distance those pictures have traveled.
Right, and one of the really unique things about this is we didn't have to send a long trailing ground wire with these vehicles.
I'd like to have that contract to produce that wire.
Yes, you're absolutely right.
Now, the vehicle, or the delivery vehicle, launched about, how long ago did it leave Kennedy?
I'm going to guess about 8 months ago.
So it's an 8-month journey time from Florida to Mars.
Right, through some pretty nasty environments. Not many radio stations, but a lot of other RF noise.
What kinds of environments would they encounter along the way?
Mostly high energy particles from the sun. That would be electrons and protons and other parts of plasmas that exist here in the space.
What about interference from other spacecraft that are orbiting satellites? Are those issues in the launch phase?
During the launch phase, we're very careful not to have that happen by examining the environment, the launch environment, and controlling that. We actually make certain that launch radars are kept to low levels so that they don't interfere with the operation.
Right.
Unfortunately, not everything is under control of the launch site. At Kennedy, for example, we're right on a port where we have incoming cruise ships, and they have their radars, and we have radio stations and television stations, and those all have to be accounted for.
Interesting. Now, there's no return journey for this vehicle. When it's done, it stays there. Is that correct?
Oh yes, this was a one-way trip.
A one-way ticket. Sad news for Curiosity, but good news for us if it can deliver the content.
Right. Yes, you're absolutely right. I'm not sure Curiosity cares.
Well, it's been very interesting talking to you, Ron. Thanks for stopping by this afternoon, as ever.
All right.
Great to listen to more space stories.
Oh, yes. We'll certainly take care of that.
Thanks to Ron. This is Graham Kilshaw for Interference Technology. More news later.